Hey guys, CWHolo1 here. Welcome back to another video, and today we're here with the next addition to my collection. This is Lionel 6-38044. It is a Pennsylvania Railroad K4, numbered 5385, with TMCC and Rail Sounds 4. And this should hopefully be an easy repair, because all it has is a blown marker light on, I think, the pilot beam. I need to power it up and remember. But because it's me, I'm sure it's going to be an absolute nightmare to change that. So stick around and see how this goes. So up front, yeah, we're missing the fireman's side marker light. The lights on the pilot beam are markers, and the lights on the smoke box are class lights. Until a certain point, and then they got rid of the smoke box ones on on road engines and kept them on yard engines, and then they got rid of the class lights on yard engines but kept them on road engines, and then it got really confusing. But I'm pretty sure that's how that went. And yeah, these lights are wrong. These ones are technically, they could be correct. Green class lights indicates the first segment of a train, or the nth segment of a train that isn't the last one, and then the last one runs marker or class lights off. The markers are just wrong. They should be red and orange, but I'm just going to stick with the green because that's what Lionel put in it, and I think it looks neat. Also on the back of the engine, it's got the 3 red lights, which are wrong. The middle light is supposed to be a reverse light, but for some reason Lionel didn't catch that, and they just put a red light in it. So that's what it's got. I am currently attempting to fix that in my E6. That video has been ongoing for several months now, so I don't think it's going to happen in this video with this engine, but if I ever figure it out with that, I will probably implement it here. But yeah. Also, another note, if you're wondering why the proportions on this engine look wrong, it's because they are. Lionel, when they designed this thing, just reused whatever Heavy Pacific chassis or whatever it was that they had at the time, which I believe they also used for like the B&O Pacific that they made, the Erie Pacific that they made, and a couple of others, which is a good cost-saving measure. The problem is that the chassis is like, I think, a 2 scale feet too long or something like that. So what they did was they extended the firebox, but kept the boiler dimensions roughly the same, which I think is the correct way to go about fixing that if you're going to be lazy and just reuse the same chassis. From a cost-saving measure, I think it was a good idea. The extending the firebox doesn't look as silly as an extended boiler, but because the proportions of this engine are abnormal and excessively large, that means that there's a possibility that if I ever really want to take on a big project, I could design a K5 boiler for this thing. If you don't know what the K5 is, the K5 was an engine that the PRR experimented with. They had 2 of them. One of them was made by the Juniata shops in Altoona. The other one was made by, I want to say, Baldwin. And it was basically it was a bigger K4. It was supposed to have bigger tractive effort, but what ended up happening is it actually reduced the tractive effort because it added a bunch more power for not a whole lot more weight. So they couldn't really make that one work, which is why there were only ever 2 of them. And it ended up being a template for, I think, Caprati valve gear, which is what, I think that was what the Baldwin one had. I can't remember, but I'll do more research on it if that ever happens. But there's an option for that because the chassis, I think, is about the same. And it actually has the correct size drivers. It's got 80-inch drivers, which is pretty neat. But yeah, so that's why the proportions on this thing look a little weird. Alright, so I am actually going to fire it up because I want to make sure that... oh yeah, it's got that issue too. I want to make sure that everything else works on it. So. The motor seems to be fine going forward, with the exception of speed step 1, which is a little jittery. Same thing in reverse. I need to turn that down, holy smokes. Direction's fine. Rear coupler opens. Whistle works. Bell works. Crew talk works.
Pennsylvania 5385, you are clear for departure.
Tower comm works. 6 makes a little sound. 3 makes blowdown. I have the smoke turned off. I should probably actually test that. I know volume works because I tested it. aux 2 actually works for the headlight, which is nice. Yeah, boost works and brake works. Okay, so I remembered 2 more things I want to do to this engine now. The first one is I want to try to figure out why I can't reprogram it. For some reason, this engine is stuck to engine 1, and I have tried to reprogram it before, and it literally just would not take a command. So I've tried resetting the R2LC, and it still wouldn't do it. So I'm gonna have to do some reading and try to figure out why that's the case. The other thing I want to do is I want to try to give this thing 4 chuffs per revolution. If you guys follow my channel, you probably saw I uploaded a short, I don't know when this video is coming out, but I uploaded a short a little while ago where I upgraded a Weaver Models Reading G2SA to 4 chuffs per rev by 3D printing a cam. I don't know if this engine uses a cam or if the Odyssey system uses the magnet wheel that's attached to the flywheel or the magnet ring that's attached to the flywheel to detect chuff. But we're going to figure that out, and I'm going to see if I can give this thing 4 chuffs per rev, because there's got to be some way I can fudge it, right? Okie dokie. This thing's heavy. I mean, it's all die-cast, so it makes sense. But, yeah, thing's got some weight to it. Okay, whoops. Let's see if I can figure out how to take this shell off. I have not had this off yet, so I don't know what I'm going to find in here. For all I know, it could be totally cooked. Oh, you know what? I didn't test the smoke unit. Really? Okay, well it's hopping, so it's probably fine. Smoke unit was on. It's in run. Oh, okay, we're good. For a second, I saw the E-ring on the front truck and was like, oh boy, that's gonna be a fight. Me and E-rings do not get along very well. I actually bought a whole bunch of them to work on couplers because for some reason I am incapable of keeping them. They just eject themselves somewhere into the void. I bought a magnet to try to find them. It did not work. They're just gone. Okay. I like how this comes apart like a brass engine where it's got 3 screws in it. Alright, there's one. I want to try to... Didn't work. Let's try it again. There we go. It's like the little Lego launcher things. Alright, what am I looking at? Let's... Yeah, well... Apparently that decided to remove itself. There's the cab light. I always find this amusing. Let's put plugs to, you know, connect stuff, and then we'll put a wire nut in there too. You can't separate the shell if it's joined with a wire nut. At least not easily. But that's the antenna, so I sort of get it. I love the fact that there's just epoxy or resin or something down here. Oh, what do you know? The double-side sticky wire hold-down tape hook thing. Those guys. Doesn't stick anymore. Yep, makes sense. Alright, smoke unit honestly looks like it's in pretty decent shape. Probably just very dry. Boards look to be in good shape. Motor's actually attached on this one, which is convenient. And it looks like it does actually use a cherry switch. Huzzah! Okay, so I gotta get this board off and measure the diameter of that so I can start printing a cam for it. And then, yeah, okay. Step one, separate. I don't know if you guys like the long-winded stuff or the short-winded stuff more. When I just kind of show you that here's the thing, here's how it works. Big old plug here too. Oh, wait. Am I really gonna need to pull out? There we go. Okay, what is this? This is all of the class lights and the headlight. This is the antenna. And where did that other plug go? Oh no. Sorry. This is the headlight. These are the markers. This is the antenna. Neat. Now then, let's try and get this board off without deleting on all these wires. You know you have an engine that nobody's ever been in when you go to take the bolts off and it does that nice snap. That's when you're breaking the factory torque loose. So I need to figure out how the heck to rotate this out. Let's remove the R2LC. Hey, okay. I can maybe work with that. What is going on here? Oh, you know what? It is probably intended to pivot that way. Yep, that was way easier. Yeah, that is a thing with these engines. When you work on these, sometimes the boards are designed to be serviceable, but only in one direction. And I found that I always like my engines pointing to the left of me, and whenever Lionel designed these, they designed them pointing to the right. So if you're struggling to get something out, try pointing it to the right, and maybe that'll help you get your wires. Because, like, for example, here, there's a wire that goes through this board that's limiting you from pulling it this way. But you can spin it that way, and it doesn't bind up with anything. So, neat. Okay. Oh, I forgot about that. Captured drivers. Yay. Okay, there really aren't that many plugs on this thing, so I think I'm just gonna pull them off, because if you don't know what I mean by captured, when I say something is captured, in engineering/design lingo, what that means is that it is installed in a way that it cannot be removed, at least not without great effort. So, for example, in my line of work, we use captured bolts on things like solenoids and servos when they come from our suppliers. And the reason we do that is so that they can be a replaceable or an easily replaceable unit where the screws are already installed. And it also prevents the chance of those bolts coming out and falling into, I don't know, the engine, because jets. So if you want to know what happens when bolts come off of engines, look at the Concorde. So, or rather DC-10 and what it did to the Concorde. But that's why we use captured bolts. Now, why Lionel uses a captured driver set on all of their engines, really, is beyond me. Because as far as I can tell, there really isn't a great reason to do it, other than maybe they have a patent on it or something. I haven't looked that far into it. Oh, I see now. Okay, well, I'm going to need to desolder that before I can remove this board. Fun! So that wire gets stuck is actually soldered to the reed switch. So I gotta get my soldering iron out. But yeah, so I don't know why they use captured bolts or captured axle sets, because you can't service them. Oh, I'm missing traction tires, but I have traction tires. I remember I bought traction tires for this thing. That was the other thing I needed to replace. So there were 4 things on this engine that I needed to fix. You can tell how great of a job I do documenting everything when it's my engine versus when it's somebody else's. Okay, so I'm gonna put this back in so that I remember where that goes. Desolder that, and now I've got that removed. So sweet. Alright, that gives me a lot better access to what's down here. I'm gonna need to remove the motor driver board too. Alright, let me just start blowing this thing apart, and I'll let you guys know when I can actually get to that reed switch. So here's what we're dealing with. This is our cam, and it has a little slit in it so you can, adjust it and whatnot. Unfortunately, I have no idea how to get that out in a way that isn't completely destructive. So I'm going to try and do it the least destructive way, which is I've got this flat blade X-Acto here. I'm just going to try and basically cut down through the top and try to cut down to the axle. I have no idea if this is going to work or not. It somewhat worked on the G2, but obviously this is a very different sort of setup here. With the G2, I had the axle fully removed from the frame. An ultrasonic knife would probably make really light work of this, but I do not have one, so. Nope. Okay. Hey, there we go. Okay. So that, in theory, should now be removable. Oh, there it went. There's one half. There we go. All right, cool. So now I can take my measurements and get a new cam printing for that axle. So this is pretty wild. In order to get the marker lights out, you remove the signal box, which gives you access to these 2 screws, which allows this to start coming off, but you're going to be fighting these wires, so you have to unscrew this plate, which lives on the bottom of the pilot, and that allows you to pull the marker lights out, and then you can remove the pilot. So that's fun. Very convoluted process, but sure. These are the replacement lights I have. They don't have the long lead lights that these are. So what I'm going to have to do is I'm going to have to snip these and solder them in here and hopefully make the joint small enough that it just fits under the pilot underneath this little connector thing. So let me get started on that and hopefully it goes well. So this is pretty cool. I was actually able to remove the old light without cutting the wires. And the way that I did that is I literally just pulled on it, and you can see that the leads are starting to come out of the wire. So I just need to do a good job remembering which one is red. So this one is the red one, which means that one has to slide into that one. Yeah, this is going to be the struggle, is actually getting them to go back in, because I just pulled them out of whatever really tight fit they were in, so now they're not going to want to go back together. So I'll fight with this. I'll see if I can get it to work. So I've got power on the track, and I've got 2 LEDs. So I'm going to say that's a good fix. I did put a little bit of heat shrink on This guy, just to keep the wires clumped together, I had to trim down the leads a lot. Also, there's a little red dot on... You're not going to be able to see it on this guy. On the new one that I just put in, there's a little red dot on that white circle that goes around it, on the white rim, and that tells you which side is positive, which is very convenient. But anyway, let's try and put this thing back on. Way easier said than done, but holy cow, they're in finally. I did have to remove the smoke unit to give me enough wire length to actually like pull them out and fish it through the little channels that are in the bottom, but they're in and they're both lit, so I am happy with that. So now I got to start putting it back together, and I think my cam just finished printing, so I can get that ready to be mounted up. Okay, here's what we're looking at. This is a half of it, obviously. The other half's there. It's just a square with a hole punched out in the middle of it, and then I cut it into two pieces so that I could just slip it on. I'm going to have to glue each half, and I'm going to have to score the axle too, because super glue does not stick well to smooth surfaces, because it uses the imperfections and jaggedness of a surface finish to actually create polymer bonds with whatever it's mating with. So the smoother the surface, the worse it sticks, which is why it doesn't really stick well to office paper, but it sticks really well to your fingers, because your fingers are not very smooth. That's the plan. I'm going to go see if I can get this to line up, or to stick, and I'm going to line up my corners with my crank position so that I hopefully get the chuffs on, 0, 90, 180, 270, top right, bottom left, whatever you want to call it, the normal positions. Alright, it's in. It needs to dry still, but that looks pretty well straight up and down to me with the crank at bottom dead center. So I am quite happy with that. It's not really sticking great as I predicted because it's smooth surfaces, which is why you can just see glue slathered everywhere. But I think if I just let it sit for a couple hours and probably come back to it tomorrow, it should be pretty well set up, and I can put the limit switch back on and actually test it out, because I can't test it in its current state because the limit switch has got enough recoil in it that it will probably dislodge something that I don't want it to dislodge. But by the way, I am going to, if I can pull the switch out here, I am going to bend the end of this switch up probably just a little bit to help prevent it from snagging on that ridge when it's going in reverse. It's something that I learned when I was working on the G2, and it's probably something I'm going to incorporate every time I do one of these upgrades because it worked really well. So, anywho, I'm going to let this dry, and I will see you guys when I'm ready to put all this back together. So, update, it hasn't been that long. I was just poking at it just to make sure it wasn't going to slip off while I walked away from it, and that is like rock solid. I have no idea why, but sure. Also, with the limit switch, this is what I mean by bend the end of the switch up. It's just, I took my pliers and grabbed the end and bent it so that it doesn't get hooked when it's going backwards, because that edge will snag it and it'll tear that cam right in half if you don't have that bend. So anyway, I guess I get to start putting this back together now and make sure that the chuff rate is actually what I want it to be. So all this has to go back on. So this is actually attempt 2. Attempt 1, I had the old 0 chuffs per revolution. The cherry switch in this is actually a normally closed cherry switch, and it's toggled open when the contacts are closed, which is interesting. And what that means is this thing is chuffing on the 45s and not on the 90s because it's triggering the chuff when the reed switch drops back to being on one of the flats, and not when the reed switch gets closed. So I'm debating if I want to fix it. I don't know if I really want to take the whole thing apart again. It's got 4 chuffs per revolution, and realistically, when this thing's moving at speed, you're not going to notice that it's on the 45s. And if it really irks me later, then I'll fix it, but I'm used to the 2 chuffs per revolution, so this is a massive upgrade in and of itself. But yeah, so that is that upgrade complete. Also, I just did all this testing to try to figure out where these wires went on all the boards to figure out why the run program switch wasn't working. And I should have just started here, because I have it in program mode right now, and these 2 pins aren't connected, which means that this switch is cooked. Yeah, never would have guessed that. I didn't realize these things could go bad, but apparently they do. Also, I looked at the smoke unit, and I realized how black these terminals are. And I have the smoke unit is on, and I'm not getting power to the fan motor. So either the fan motor is blown, or at least the fan motor is not turning. So the fan motor is either blown, or I'm not getting power to this board. So I'll have to test that out next. But yeah, I'm going to real quick see if I can jump this and maybe get my engine programmed to, I don't know, probably 85. Worked like a treat. So now I can do engine 85, and it fires right up. And I just bridged it with my alligator clips, and sweet, I got it programmed. So add that to the list of things that I need to replace. I've got a million of those switches, so it's not going to be hard. I just need to actually, like, okay, be quiet. I just need to actually, like, desolder the switch and flip it out. That guy's next. I got to see if I got power, and I got to test out that resistor. I don't know what happened, but all of a sudden I've got power to that smoke unit, and fan's running. Feels like it's a little warm. You can hold down the 9 button and boost the heating element. Oh yeah, I am seeing, there's a little bit of smoke coming out. How about that? Sweet! Oh, that's really nice, actually. See, now the problem is, I have to switch out that switch now, because I don't want to come back inside of this engine. Oh well, guess I'm doing that. And then the shell goes back on, and then I'm done. Alright, shell's back on. Last thing to do is put on these traction tires. I did also realize that I do have driver sets in my little kit that are metric, and sometimes they fit. And if it doesn't, then I get to actually use my standard ones. But basically, I'm just going to be removing this this one bolt here and trying to bend the side rod out of the way. Hopefully I don't have to remove the eccentric and the front driver to get that out, because these aren't segmented. But yeah, that's the idea. Just basically pull that out, and then I have 1-inch somewhere. I have a whole bunch of 1-inch traction tires. Here they are. That's the part number for them. These should fit 80-inch drivers, which is what this is, and my G3 and my G2 and New Haven i5s, and yeah, they're all 1-inch traction tires. So I fought with it for about like 15 minutes and then realized that if I just take the shell off, I can do it in seconds, and yep, just remove the 1 screw up here, the 2 screws back here. It makes this way easier. but they're on now. So I didn't need to take off the eccentric crank or the front axle, just this, or the front, what do we call them? The pin thing. Just the back one, slip it on, wrap it around, and that is good to go. So let's put this back up on the stand, give it one last test, make sure that everything is still working the way that it should, and box it back up. Okay, please just work. I would like to go to bed. Engine 8.5. Did put some smoke fluid in it. We'll see if anything actually like comes out. I'll give it a minute to warm up. Okay, let's step it out. It's so funny that it's on the 45s, but whatever. This thing looks great with all the marker lights up front, or the marker and class lights. Don't want to run it too quickly until that glue sets fully on the cam. Oh, that's weird. It's like surging in reverse. That's okay. I couldn't explain that one. Oh, hey. There's actually smoke. Okay. Maybe that'll get fixed with runtime, and if it doesn't, it gets fixed in another video, because that's where I'm going to call it for today. So there you have it. As I kind of predicted, one repair turned into many, and this took a lot longer than I thought it was going to. But I got to put in a new marker light, I got to fix the smoke unit by doing nothing at all, the run program switch works now, and it's got 4 chuffs per revolution on the 45s. But yeah, I love how easy this engine is to work on. I'm tired and I don't want to tear it apart again, and I just want to put it back in the box and go to bed. So if you're wondering why the LEDs blow up so frequently, if you have TMCC engines, I'm sure you've dealt with it. It's because they don't put a diode in line with the LED, so the LED is seeing both sides of the waveform that's going through the rails, but it can only be on for one of them, and then it's being back-driven by the other, and I think that causes them to wear out a lot faster. So if you put a diode in line, they should last longer in theory. I did not do that because I didn't want to, and I'm not too concerned about these blowing up again because I'm trying to find replacements. Trying to get these 2mm LEDs from Lionel is very difficult, so I'm trying to source some sort of LED from, like, I don't know, Lighthouse LEDs or maybe something off DigiKey. And it's proving to be a lot harder than I thought it would be, but I think it's doable. I have to figure out what the supplier is. But yeah, so if you guys have any questions about anything that I did, or you think that I should have done something differently, or you have any feedback for something I could do better, feel free to drop a comment down below. I love hearing you guys' feedback and basically you guys yelling at me, telling me I'm doing stuff wrong, because that is how I learn. I can't learn everything myself, so I need somebody to teach me. And most of the time that's you guys, so thank you all. But yeah. Anyway, hope you all enjoyed, hope you all learned something. I'm CW Hollow 1, and have a good day, or maybe good night in your case. See ya.